So welcome to the lesson on breadboards. It turns out that breadboards are also known as prototyping boards, or one of the most important tools that an electrical and computer engineer has. But you need to understand how they work to be able to benefit from their amazing characteristics. A breadboard really offers the opportunity to connect wires together temporarily and very easily just by pushing those wires into the holes. So if we look here on this breadboard, it's important to know what holes are connected together electrically. Now you'll notice that I've put the red stripe across the top of the board here, and that means that there's a blue stripe along the bottom of the board. There's also a blue stripe on the top, and there's a red stripe on the bottom as well. But I always try to put the topmost red stripe the furthest away from me. And the reason for that is because this red stripe is typically used to supply power to all of the circuits that you're going to be working with. And down here, the blue stripe is used to provide ground to all the circuits you're going to be working with. It might be desirable, for example, to connect this blue stripe right here with this blue stripe down here. So just a single wire that connected any two holes on these two stripes would connect those two blue stripes, and then any two holes here connected would connect those together. That means, for example, that if you supplied power to the top row and ground to the top blue row, then they would also be supplied to the bottom two rows as well. Now inside the body of the board, it's any of these 5 pairs of holes will be connected together. So vertically rather than horizontally on the outside, these 5 holes are connected, these 5 holes are connected, these 5 holes are connected, and so forth. But these 5 holes are not connected to these 5 holes, and that's very important. The stripe that leads down the middle of the breadboard separates it into 2 halves. And only the top 5 are connected, and only the bottom 5 are connected. This means, for example, that if I wanted to place an integrated circuit onto the breadboard, what I would want to do is not to put it down here, because if I put it down here, the top and bottom rows would be connected to each other, but you always want the breadboard to straddle the midpoint of the board. So that here you can see, now I have direct access to plugging into any of these 4 holes, and any of these 4 holes would connect directly to that pen. So you can see here that the pen is directly inserted into the sort of innermost stripe there, and the same thing over here. This pen is inserted here. So I have 4 places that I can connect to any of those pens. So for example, it's very common in a circuit like this that I would want to apply power to the top left pen. That's known as pen number 1. And what I would do there is I would simply connect a wire between the red stripe, which is up here, and that pen right there. And now I've supplied power to that part of the chip right there. And then very often you'd need to apply ground to the bottom right pin. And so I could just put a wire into the ground stripe, and I could put a wire into the bottom right pin of this chip. And when I've correctly inserted the wire into both of those holes, then this chip would be correctly powered and grounded. So now we have that chip is ready to go. And other things are going to, of course, need to be connected to the other pins, but this is how the chip needs to be configured as a minimum. One thing to notice, and I don't know if you can see this in the video, there's a notch right here on the left side. And that notch always goes on the left side. So I don't know how well you can see the notch there, but it always goes on the left side. And if you forget, you can also see that there, perhaps you can see on your chips, there's also letters on the chip themselves, and they need to be legible when read from this direction. So what you're going to need to do is you're going to need to connect power from the power supply to the red stripe, or to both red stripes, and ground from the power supply to the blue stripe, or perhaps to both blue stripes, and then you're going to be ready to go. Now it's possible that you'll have a project that's so big that it won't fit onto one of those single breadboards, in which case you're going to have a larger breadboard that looks like this. What this actually is 1, 2, 3, 4 breadboards all connected together to the same piece of metal, and then extra power and ground strips up here. And furthermore, there are some posts over here that we can use to connect, for example, plus 5 volts to the red, maybe plus 12 volts to the green, minus 12 volts to the blue, and 0 volts to the black. Typically, for many of our applications, we're just going to use the red and the black. And the red will be attached to the red stripe, and the black will be attached to the blue stripe, because both blue, cold or low temperature, is sort of representative of low voltage, and black are both used to represent the ground connection, or the common connection. And so it's important to realize that this blue stripe and this blue stripe and this one and this one and this one and 2 more off the bottom of the screen here. All of those are totally separate from each other. And if you want them to be connected, then you have to connect them together yourself. So that, for example, you would want to connect a wire from this blue stripe right here over to hop over to this blue stripe. And if you had connected, say, this one to this one, and then this one to, say, this one, well, now you've distributed the ground effectively across all 3 of those. So 1 wire, then 2, 3, 4, 5, 6 wires would be sufficient to distribute the ground across the entire board. And then anytime that you needed to access ground anywhere on the board, you just would plug it into the nearest blue stripe. Another 6 wires would allow you to connect it to the power supply, and then you'd be all set. So you'd have the voltage and you'd have the ground. Whatever it is that you needed, they'd be readily accessible to you. So you probably won't be faced with a project that's big enough to require a board like this for a while, but when you do, it's good to remember that these are separate boards. I could actually pry this up, and this would actually be a separate breadboard, and this would be a separate breadboard. So just remember that the connections don't exist unless you create them.